here's the circuit we're using. This is what we'll end up building. Let me minimize that. This is what we should have had from last week. And let's go ahead on this file. So far all we've done is we've commented out this line, digital write LED pin button state, because we're going to manually control this button. Let's go ahead and save this as and call it touch IO. All right, I'm going to call mine 2 because I already have one called that. All right. All right, so the next thing I wanted to show you is this this post, which was so helpful to me. It's on the Arduino forum, and I'll put a link to it on the website. I don't think I have yet, but this is, if you want to follow along, that's the website. Arduino forum, yeah. If you just search for serial input basics updated, you should be able to find it. Arduino serial input basics updated. And well, I'll just read some of this to you because this was really helpful to me. And I think if we go over this really quickly, it'll help make clear what we're going to do today. Okay. So this is, the guy says, this is a revised version of an earlier thread. That doesn't matter. All right, so in this post, he goes over 5 different methods. Well, 6 different methods, but we're not going to look at the 6th. 5 different methods of communicating through serial from a computer to your Arduino, that direction, instead of from the Arduino to your computer, which is what we did last week. So the first way we look at receiving single characters, and second way is receiving several characters from the serial monitor. And what I mean by characters is these are strings as opposed to values or bytes. The third one is a more complete system of sending an unknown length of string characters, such as like typing in someone's name or something like that. And 4, receiving a single number from the serial monitor. And 5, which is actually what we're going to be using today, receiving and parsing several pieces of binary data. All right, so newcomers often have seem to have difficulty with the process of receiving serial data on the Arduino, especially when they need to receive more than a single character. The fact that there are 18 different functions on the serial reference page probably doesn't help. You could write a small book about every different possible situation about data reception, but rather than write a book, he decides to just show you these 5 main things, right? So first thing to understand, serial data is actually a lot slower than the Arduino is capable of functioning. So it's slow by Arduino standards. If you're sending in serial commands at a 9600 baud rate, that's 960 characters per second, with a gap of just over a millisecond between characters, and the Arduino can do a heck of a lot in a single millisecond. Even at 11.5200, the baud rate is still 86 microseconds, which is possible to do over 1,370 Arduino instructions in those 86 microseconds. So if the point there is that if you are using one of those functions that I talked about, parse int, parse float, read bytes, or read bytes until, you are hamstringing yourself because you're not able to do other Arduino functions until the Arduino reads at that really slow rate. And that's what this whole thing is avoiding. Okay, so receiving single characters. The way this works is he's defining a character called the received character, and this is a variable. This will change as you're reading it from the serial buffer. And then he has a flag a Boolean flag called new data, and he's setting that to false. You don't have to code this yet. This isn't the method we're going to use, but we're just going to start at the beginning and move from there. All right, so serial begin 9600, print line Arduino is ready. Then he defines a function called receive one character, and then another function called show new data. I think he says up in this thread, he says he defined these all as functions because it's easier for people to copy and paste them into their own Arduino code. So the first thing he does is this receive one character, and that's defined here, void receive one character. And this is the main thing to notice is that if serial available is greater than 0, then read serial.read into the variable called receive new character and set the new data flag as true. So you're not parsing anything, you're not reading bytes or anything like that. You're just reading the data that's in the serial buffer, if there's any data in the serial buffer. So whenever serial data comes into your Arduino, the serial buffer will start to fill up. I believe Arduino Unos have 64 bytes of available serial buffer. So as soon as a character comes in, the serial.available would return a 1. If you sent a string of 10 characters, it would be serial.available would return a 10. So as soon as something goes above 0, goes ahead and reads that data into the serial read, sets the new data flag as true. Then he defines this show new data to actually print that out and says if new data equals true, meaning if there's actually new data there, not what we had the last time we read it, go ahead, print this just in, and serial print the received character, and then set the new data flag to false so that the next time around it can, if something new comes in, it'll read it. Question?
Yeah. Sorry, I'm just trying to parse that in my head.
Serial parse?
Yeah. So this can take like 960 characters per millisecond or second?
Well, no, 960 characters per second.
Per second. And
yeah.
You have to set it to that.
If you're on 9600 baud.
It can take more than that.
But it can only, the buffer will fill up after 64 characters.
With what this code is adding, the buffer.
Yeah. But here the buffer, as soon as, when the buffer fills up, it rolls back to the beginning. And every time this runs through its loop, which it will run through its loop way faster than 1 second. Okay. So it should never, the buffer should never completely overflow because it'll just keep reading it.
Whenever some new information comes in.
That's right, yeah. And when the buffer fills up, it'll go back to the beginning of the buffer.
So after 64 things of new information, it will go back to
It'll go back to 0.
New information.
So like if you were sending the numbers, well actually if you were sending the numbers 1 through 64, once you got past 9, you're actually using 2 things because you're sending a 1 and a 0, 1, 0. But if say you're just sending a byte, which can go, as a binary value that goes from 0 to 255. That only uses 1 character, right? So if you're sending a sequential set of bytes from 1 to 64, when you get to 64, then the serial buffer would overflow and would start to put it back at the beginning. And if you read, so say you were sending bytes from 0 to 255. Once it got to 64, it would start putting 65 back at the beginning. And if you read it all out, then it would be 65, 2, 3, 4, 5, 6, 7, 8, 9. So it like rolls like that. Okay, does that make sense?
Yes.
Okay. All right. So here's where he talked about why it was organized into functions. Okay, so that's pretty simple. All you're doing there is whenever there's new data, you're printing it out. You don't have to worry about parsing because you're only sending a single value. All right, receiving several characters into the serial monitor. This sounds like what we want, but this is more set up. This particular example is more set up for dealing with characters like you would send to an LCD screen or just print out, but not numbers, which we're actually, when we're going to be turning on and off lights, and when we use the servo motor, we're going to actually want values. So that's a further down example, but this is still handy to understand. So this is receiving with an end marker and receiving characters into it from a string. So you starts with a constant byte called the number of characters. This is basically the maximum number of characters that this program will look at. So even though the serial buffer can take up to 64, he's defining a maximum number of characters of 32. That way there's always some extra space in the buffer, because you're going to want extra space in the buffer for your end of message character and other things like that. You also just don't want to use, the more of the serial buffer you use, the more RAM you'll use on your Arduino. If you don't need 64 characters at once, then use less, because it'll make your Arduino run faster. It'll make your Arduino have more RAM available. You may need 64 characters if you're trying to like print out a big long message on an LCD screen or something like that. But for our purposes, we're only going to need like 10 characters to define all of our different numbers, right? All right, so he's defining up to 32. Doesn't have to, it won't necessarily use all 32. So receive characters. So he's storing this in a char character, a string, and this is an array. Whenever you see brackets like that, it's defining an array of values that you can iterate through by calling an index number. So he stores the incoming values into this array called received characters, and the length of the array is the number of characters, in this case 32. And then also he's using this new data flag. All right, and so then starts the serial at communication at 9600, and does a print line of Arduino is ready, and then uses these functions, receive with end marker, and then the show new data. So here's the receive with end marker. Has a static byte index. So that's the index that's going to point to this particular character in that array that you're defining, and an end marker, in this case new line. This end marker is also often called Terminator, and you'll see it in the Arduino in TouchDesigner when we call our serial output functions. There's a thing called Terminator, and in this case it's using a /n, which is the new line character. And then has a variable called char RC. I think RC stands for red character, meaning the character that you're currently reading out of that array of characters that have come into the serial buffer. And while serial is available while serial available is greater than 0, meaning there's something in the buffer, and new data is equals to false. So what this does is when there is new data being read into it, it doesn't read it, because it wants to wait till everything comes in before it reads it. So it won't do this function unless the new data is set to false, meaning everything is in the buffer that's going to be in the buffer for that cycle.
So it gets set to false once it reaches 32?
I believe it gets set to false. First it gets set to false at the top of the program before anything comes in. And so the first thing that comes in, it will read it because it's currently set to false. But while it's reading it, this function will actually say new data equals true while it's reading it. That way it doesn't try to read it again before the rest of the data comes in.
Okay.
So yeah, serial read, the red character equals serial read. If the red character does not equal the end marker, then go ahead and put the store the received character in the array called received characters with the current index value. So received characters array, the current index value equals the red character, your current red character, and then go ahead and increment the index value. Then if the index value is greater than or equal to the total number of characters, 32, the maximum total number of characters, then set the index character to the number of characters minus 1. So if you overflow, go back to 30 and 31 and wait for the end of line character. And so what that'll do is it'll just truncate the message at 31 characters and wait for the it'll wait for the Terminator. If you try to send a 64 character message, you'd only get 31 characters and wait for it, and it would just keep going back to index 31 until it got the Terminator message.
Index 31 would constantly be replaced until this end marker came in.
Exactly.
And the line above that, sorry. So if it does not, if the end thing hasn't been sent in yet, then it's adding to an index?
Yeah, so the index, you're storing the values in an array that is up to 32 characters long.
Okay, and then the last one's, okay.
And great. So yeah, so this just truncates that last character until it gets the end marker. Okay, so then if it's not the end marker. So then else means it is the end marker. And if the received character equals the received character index equals /0, which is a null character, terminate the string, set the index back to 0, and turn the new data flag to true.
So all this code is doing is reading the new data and we're setting it?
Yeah, and this is basically this is kind of what those serial parsing or functions do behind the scenes, but this is a method of doing that without stopping the Arduino from doing anything else. And then go ahead and just print this out, and it prints out whatever is in the received characters. Okay, so that's method 3, or method 2. Method 3, I'm not going to spend too much time with this. It's basically the same thing, I believe, but let's see. This system, yeah, so he says the simple system in example 2 will work well with a sympathetic human who does not try and mess it up. But the computer or person sending the data cannot know when the Arduino is ready to receive. Is a real risk that the Arduino will not know where the data starts. So this one adds a starting marker as well. So if the buffer had overflowed back to the beginning or something, instead of printing out, here's an example. He says, if you like to, let's see. So you're sending QWERT, and you see that it behaves exactly the same as when you're using the new line end marker. But if you try this, ASDFG end marker ZXCVB for some reason, you shouldn't have put anything after the end marker, but you did anyway. You only see the first part, ASDFG, because then it did its thing when it saw the end marker. But that all this stuff, this ZXCVB, is still in the buffer, and so the next time it reads, it'll get to 32. Yeah, the next time it'll read, it'll start with those extra characters, ZXCVB, and then QRWT. So that might mess you up. So this example, he adds a start character to keep that situation from happening. And so it's really, I don't want to go as in depth on this one because I want to spend more time on the number 5. But basically, he defines a start marker now, and so it ignores characters in the buffer before the start marker. All right, it works in much the same way as in method 2. It just adds that. Here's where he talks about why you shouldn't use serial parseInt, parsefloat, read bytes, or read bytes until. And there's also another one called serial event. Sometimes you'll see in some examples, and he says he doesn't like that, doesn't recommend it, because he prefers to deal with the serial data in a more direct way, because it will behave exactly how you program it instead of how the function, the pre-programmed function, wants to deal with it. Let's see. Well, I don't need to talk about that. All right, so example 4, receiving a single number. So now we've moved on from just characters, and now we're working in numbers. You have a, let's see, is this even worth looking at? Basically what happens here, it's still using the same thing. I believe all he does here is just cast it as a, yeah, okay. So the only thing really in this example to know is it's still pretty much the same example as before, as method 3. It's just that you cast the string as an integer using this function, which is an inbuilt function in Arduino called A2I, which is ASCII to integer. And we'll be using that in the next one. It basically turns the character, the string character that comes in, yeah, A, B, C, D, or 1, 2, 3, 4, when those come in, if you're sending them in as a string, which actually the method that we're going to be using in TouchDesigner sends things as strings rather than as bytes. So if you sent it as a byte, then it's a number, and it's a number that goes from 0 to 255 maximum. But the method for sending things out of TouchDesigner, if you're sending bytes, you can only send 1 byte. And so then you can only send 1 channel of data. And we're going to end up with 3 channels of data. So instead, we have to send it as a string. And so it'll come into the Arduino as a string, and we have to then convert that string into bytes or into values.
So we can read it as a value rather than just a character?
Exactly. Because a character 1, as in I'm going to print a 1 on this LCD screen, is different than integer 1, which is a byte. Well, it's actually, it's a byte is only 8 bits and has a value of 0 to 255. Arduino, when you define an integer, it's like a 32-bit integer and can go from like 0 to like 1024 or something like that. So this will actually change that character into an Arduino integer. And so yeah, so he uses that in this version. I don't want to spend too much time. I want to spend more time on this one, example 5, receiving and parsing several pieces of data. Okay, so same thing. You have constant number of bytes. The input, in this case, just defined that at 32, even though you could define it all the way up to 64. You'll have your receive characters, and you have an array called receive characters, and its length is the number of is this 32 num characters. You then have a temporary array that you copy this received array into, called temp characters, and it's also the same length. And then you have a few variables to hold this parse data. You have the message from PC. So he's doing 3 different types in this example. When we do this in our code in a minute, we're going to use all 3 of them being integers. But in this example, he has characters. The first thing coming in is going to be characters and treated as such. And it's an unknown length. Then the next thing, and separated by a delimiter, which is a comma in this case. then he has an integer. So then the next thing that comes in after the first comma will be treated as an integer, and the next thing after the next comma will be treated as a float. So same kind of new data flag. This is just the setup where it says, hey, it's ready. And this expects 3 pieces of data: first text, second integer, and third a floating point float. An example would be hello world, comma 12, comma 24.7, and also this character that is the start character, and this character here is the end character. Okay, so first thing, if there's new data equals true, then well, I guess first he executes this function, which we'll look at in a minute, and then if there's new data equals true, then string copy to the array called temp characters from the array called received characters. So just copy received characters to temp characters. Make a temporary copy, and this is necessary because he uses a function called string token, strtalk, to parse the data. And when you do that, it will get rid of the commas, because wherever you define the token, in this case, a string token means read this string with tokens, which are delimiters to separate values. And when you do that, it will replace those commas with a /0, which is a null character. So to maintain the original message, he copies it before he does that string token. He copies it into this temp characters. Then he runs the parse data function that we'll look at in a second, and then just prints out the data with a function called show parse data, and then sets the new data flag back to false. Okay, so receive with start and end markers. So you have another flag called receive in progress. You set that to false. You have your index byte to point to the specific character that's coming in. You have your start marker, which is defined as that greater than symbol, less than symbol. I always get those mixed up. Whatever that one is. Less than symbol. And your end marker as greater than symbol. And then character, you define a character called RC. And that's the current character that you're looking at in that array. And then while serial is available, meaning is greater than 0, meaning there are available characters in the buffer, and your new data is set to false, so don't do anything until you're done, until the buffer is done populating. Then go ahead and read the character into RC from the buffer. If the received in progress equals true, then and the received character does not equal the end marker, then populate received characters at the current index value with the red character and increment the index value. So that's kind of similar to what we saw before. And if the index is greater than the number of characters, then just hover at 31 until you get to the end and truncate everything until you get to the end character. Else, the received character. Okay, so then if it is the end marker, then terminate the string with a null character, set the received progress to false, set the index back to 0, and set the new data flag to true. Else, if the return character, the received character is the start marker, then set received in progress to true. Yeah. Okay, so then what happens? Then we define the parse data. This is what's important and what we'll be adding. We'll be adding a lot of this to our code, but this is like one of the most important parts of it. It's the actual parsing of the data. So you have the character and you're using this string token index. So this is where you're defining a thing called string token index. And it's a character. I'm not sure what this syntax means because this is the only time you mention string. This is the first time that you mentioned string token index. So I thought this should have been defined somewhere else. And I'm guessing this is where it's defined. I'm not sure what car times means, but I'm guessing that it just is defining this string token index as a character. String token index equals string token. This is a function that's inbuilt into Arduino. String token temp characters. So this is the temp one that you copied the received characters into, and this. So that's the array that it's looking at, and this is the token, which is a comma. So it's using a comma as a delimiter. Copies the message from PC to the string token index. So copy it. And then, okay, so then this first one is treating this as a string. On ours, we're gonna treat everything as an int. So ours is gonna be partially this part, but then instead of saying string copy, we're gonna be saying integer from PC equals ATOI string token index, and then every subsequent message will start with this null thing. So the first thing it does is it reads temp characters, and in this case stores the first thing that it gets before the first comma to a string. So that's why it's using the string copy function. We're gonna do this part here, but we're gonna, instead of doing this part here, we're gonna put this part here instead as the first one.
It will store
as an integer.
As an integer.
And then this, you could just keep adding these. If you had more than 3 values, you could just keep adding this string token index equals null comma thing. And what that will do is that then it looks at the next thing after the comma, and then the next thing after the next comma, and then the next thing after the next comma.
So what's the null doing?
I'm not exactly sure. What it's doing is it's not defining a new index. It's using the last index.
Which is an integer.
This temp char, yeah.
Okay.
Yeah. And so then he defines this as an A to I integer, and then does a float A to F. We're not going to use the float because we don't need any floats. And then prints it out with the parse data. So that's good enough for now. Let's go ahead and do it since it's already almost 2 o'clock. And you guys' heads, I'm sure, are spinning at this point.
What should I Google for this?
What should you Google? Well, I'll put the link, but I'm sure if you just Google Arduino serial input basics updated, you should be able to find this. I'll just check that. Maybe Arduino.
From Robin 2.
Yeah, from Robin 2, yeah. Yeah. Oh, you want the updated one. The second one, yeah. Yeah, this is it. Okay. All right, so let me turn my notes back on. Okay, so we're going to start by sending 2 values from touch into the Arduino patch. Into the Arduino patch, but we're going to start with the Arduino code because that's what we've been talking about. We have our touch IO thing here. We've commented out digital write, and we're going to add these serial read functions based on that example 5 in the forum post. So up here at the top, after let's see, LDR. Do I have an LDR value? Yeah, LDR value, button state, all that. No, sorry. There should be. Mine is a little bit different. Let's It's all right. I just need to figure out where this should go. Okay, it's right before the void setup. Where's my void setup? There's my void setup right here. Okay, so we're going to add const byte num_chars equals 32. Char received chars open bracket num chars, right? This is this is an array, a character array called received characters, and it's the length of the num chars, which is 32. So don't forget your semicolons. And then we're going to have another one called temp chars. And this is also the length of num chars. Okay. Temporary array for parsing. You don't have to put that, but you can. All right. Now we need some variables to hold the actual data that we parse out later. I mean, that we parse out with our functions. So variables to hold parsed input data. Okay, so we're going to have 3 different variables called value 1 from PC, value 2 from PC, value 3 from PC. Int, and they're all going to be ints. Value 1 from PC equals 0. Just go ahead and copy that and paste it below twice and change this to value 2 and value 3. Okay, and we need that new data flag. New data flag, and this is a Boolean. New data equals false. All right, then we have our void setup. Should be the next thing in our code. Now let's skip down to the bottom and add these void functions after the loop. So we have void receive with start end markers.
You also might want to check your void there.
Void
is
RECV
with
we can actually pull it from, if you have the thing open, you can pull it from there too. So it's example 5. We are going to be taking we're going to make some changes from this, but I guess we could just start with there. Let's do that. Do you guys all have this open, this particular one?
Yeah.
Let's start with this and make some edits just to save some time.
So copy from void receive with start.
Yeah, so go down in this down to where it says void received and start end markers, and go ahead and also copy the void parsed data, but we're not going to use the void show parsed data. We don't need that. So copy those functions and paste them down at the bottom. You can, if you've already wrote your receive end markers, you could just delete it. Okay. Receive with start end markers and void parse data.
We're putting this under loop.
And you put this under at the very bottom underneath your loop. After the very last, it's the very bottom, after the very last brace. Because that's the thing about void functions, you can put them anywhere. I usually put them at the end of the program. You can put them before your void loop You usually either put them before your void setup or after everything. I like to put them after everything. So does whoever this is. Okay, so let's make some edits to this. All of this should stay the same. We're still going to use receive in progress. We're still going to use the index, the start marker, the receive character. We're going to keep all this the same, keeping that all the same. Actually, this whole function is the same. What we want to make some changes to is the parsed data. So, because he parses this differently than we're going to parse it. He parses it into a string, an integer, and a float. We're going to parse it into all strings. I'm sorry, all integers. So we need to change this first line. String toke index equals string toke temp chars, comma. We leave that alone, but here, instead of string copy message from PC, we're going to change that to value 1 from PC, value 1 from PC equals A to I, and it should turn orange. Open parentheses, strtok, string toke index. Close parentheses, semicolon. And change here where it says copy it to message from PC. Just change this to convert this part to an integer. You can pull this down here and paste over like that. Convert this part to an integer. And now all we need to do is take this value 1 from PC, copy that, paste over this integer from PC to value, make it, and then change it to value 2 from PC. So this is the new line that we added. And then do the same down here and change this to value 3 from PC, but instead of A to F, change this to A to I because we're using it as an integer. Thank you, thank you. There we go. All right, so that's what this parsed data should look like. Great. And change this for in the comment if you want from integer, from float to integer. Okay, now we're going to add, we've defined these functions and now we just need to add them to our loop. So we're going to do this before we start reading the sensors on in the Arduino. We're going to take instructions from TouchDesigner first. So let's add, let's see. Yeah. So put a note if you want, input first, and we're going to use that receive with start end markers. Let me just grab it from down here. Copy so you don't have to type that big long function name. So that semicolon, that will run that function. Then we have to set our new data flag. So we'll have to type this out unless you want to grab it from the thing. It's not that much. If new data equals true. Sorry, not a semicolon, open brace. String str copy. CPY actually, CPY should turn orange. Temp chars, comma, to received chars. RECEIVED. Yes, that's right.
But it's taking received chars and converting it into temp chars, right?
Yes, yeah. I know, it's a little bit backwards, isn't it? That's the way that that function is defined, though. And then we're going to run our parse data. Function. and set our new data to false. Okay. Next thing we're going to do, and so then go outside of that brace. And now we're going to put a new comment and say actions on input. Next. And we're going to go ahead and turn on LEDs based on the first two values that we parse. So digital write LED pin, comma, and then value from value 1, thank you, 1 from capital F from capital PC, like that. And then go ahead and just copy this and paste it and change this to value 2. Yeah, and change digital write LED pin 2, not 12, 2. There you go. Okay. And actually, I'm just realizing we're parsing 3 values, and I don't think for now, until we add the servo, which was going to be I'll give you guys a servo in a minute, we should probably just comment out this third value and not use it. So down here in your Parse Data, you don't have to do anything to the receive with start end markers, but here on your Parse Data, just comment out this line and this line. So we're only defining value 1 from PC and value 2 from PC. Because we're gonna do this first, and then we'll add that back in a minute, and add the servo stuff. Okay. Yes. Yeah. I think that was the way we added them because we have LED pin and LED pin 2. You might have said LED pin 1 and LED pin 2.
It's just whatever second.
Yeah. And if you had LED pin 1 as your first, then change this from LED pin to LED pin 1. All right, that should work. Go ahead and do a verify. Make sure it compiles. And should have no errors. So figure out where you forgot semicolons. Go into TouchDesigner and make sure your serial is off. It should be off. But active, change that to off because we need to upload this to our Arduino. And oh, this is the. No, this isn't. Okay, great. This noise isn't going anywhere, right? Yeah, that noise isn't going anywhere. Okay, great. Okay, and go ahead and upload that to your Arduino. All right, so I believe now you're, what do you guys have for your, we have 11.5.200. In my version of this, I believe, let's see, I think I want to go back down to 9600 for the time being. So let's change this from 11.5.200 back to 9600. And down here on your delay 5, let's change that to a delay 10. I just don't want to risk it. That's what I have in my version that I prepared this morning, and it worked perfectly. I don't want to risk messing something up. And now go ahead and upload that again.
So we're just uploading this to the Arduino?
Hmm?
What we're doing in
Yeah.
TouchDesigner?
We will in just a second.
Okay.
But go ahead and upload this code to your Arduino. So make sure you change the serial begin to 9600, and at the very bottom of your loop, You should have a delay 10 instead of delay 5.
9600?
9600 and a delay 10 at the bottom instead of a delay 5.
Where's 9600?
Serial begin,
Okay.
9600 in your void setup. Okay. Yeah. See if you have a spelling error. Oh, you just spelled some things wrong, right? Okay, great. So tell me when you guys are ready to add code to a touch.
So it's compiled, and now I upload it?
Yeah, go ahead and upload it.
Nothing happens, right?
Yeah, nothing should happen. When you're ready, go into TouchDesigner. The same thing from last week. And let's go ahead and save this at your touch file, save it as. And what did we call it last week? Did we name it? Class something, or do we call it Blobby Sphere?
Definitely still new project, whatever.
Oh, okay. Well, let's name it, and let's call it.
I named it Arduino.
Let's call it bidirectional blobby sphere or something, or bisphere. That sounds sexual. I don't know. What do you guys want to? What do you want to call this? I had it called Class 10 because it was from 2 weeks ago. Let's call it Ultimate, because this is probably the last time we'll be doing Ultimate Blobby Sphere. Okay. You might want to put something about Arduino in there or I/O. I don't know. It's up to you. All right. Now we changed the baud rate, so we need to change the baud rate in our serial, or it won't work, right? Because we have 11.5200. Change this back down to 9600.
Which one is that?
The serial DAT. Okay. Then go ahead and point to your USB modem in your port, which is it's going to be like dev cu USB modem on Mac, and it's going to be like a COM port on Windows. And go ahead and turn your active on, and hopefully your sphere should still work. I mean, your interface should still work where you hit the button and it still does things. And I believe it's darker in here now because we have the lights off, so it probably isn't as active as it was before. But you can still like slow it down with your potentiometer. Is that all working for you guys? Great. Your light shouldn't turn on when you hit the button. You forgot to comment out that thing. You have to go back into your Arduino code and comment out the digital write. What was that? Let me see really quick. You have an error on your Arduino code when you upload?
Yeah.
Okay, what does it say? Receive was not declared in this scope. You probably have a spelling error somewhere. Or you're missing a semicolon somewhere. Okay. Well, let's try this. Go down here to the bottom. Go down to the very bottom, and wait. Which function was it pointing to in the error? Go back up for a second. Okay, so receive with start. Okay, so go grab your void receive with start and markers. No, you got to go down to the bottom and grab that thing that what it's called, void receive. Yeah. Copy all of that. No, with the void too. Don't forget the word void. All the way down to where that function ends. All the way down. There we go. Cut that. Yep. Paste it above your loop. Above the loop, yeah, paste it. Okay. Now try to run it. Now try to upload it again, and it should point to where the problem is. And there's where your problem is. You're missing a expected initializer before your if. So where's that? Okay, so you forgot a semicolon, I believe, right there. No, you forgot a forgot something. Expected initializer before if. Yeah, probably just a semicolon there. Static boolean, yeah. Try it again. Parse data. Okay, so you probably have something else, so now you're gonna have to move the parse data up to the top to figure out where you have an error. Nope, not that. The function called parse data down at the bottom. Yep, grab that entire function. Okay, put it above your loop. Yep. After that, paste it in. All right, try to upload it again, and it should point to your next problem. Oh my gosh, everything's wrong. Value from PC not declared in this scope. I don't know. I don't have time to go over it. I put, in case this happened, I went ahead and uploaded the code to the website. I would say just grab the code from the website, because we're going to run out of time if I try to go through your code line by line. So here on the website, under class meeting 12, download touchio.ino. And I believe there's one small problem with this, and it's just here. It's not really a, oh shit. Well, the one problem is I already had one named that, but I think no, that's right. Equals that not digital. Yeah, so just try using that. Upload that. Is this still set at 9600? Let me see what you downloaded real quick. I think I forgot to put that exclamation point on the version that I put on the website. Where's the one you just downloaded? Okay, open it. Well, it's because you have something already called TouchIO. So you can rename it, I guess. Is that what you just downloaded? I don't know. Is that what you just downloaded? Yeah. Try opening that now that it has a new name. Yeah, close everything, I guess. Yeah, you can save it. All right, is your touch closed? I mean, is your Arduino closed? Yeah. All right, now open it again. Just double click on that. Should. I don't know what to tell you. Maybe it's a Mac to Windows problem. Maybe you can you change it to a text file by changing the last thing to txt and then open it? Yeah. Change it to a text file and open it, copy everything, and paste it into a new Arduino sketch. Okay, sorry, we need to hurry because I want to get through this. All right. So you should see serial messages coming in from your serial buffer, right? Great. We're gonna send messages to the Arduino, and we need to add a button. So go to comp and add a button, and then let's go inside this button and change a few things. First, what do we want to do? I believe we need to go in here and actually add, in this table, we're going to, do we edit? Can't remember what I did. Edit? No. Isn't there a way to add a new column? What do you do? Left. I know there's a way to add a new column. Add after. Right click up at the top of the column and say add after. And then say, put in text here. And I forgot to put my notes on this section, which is why I'm a little funky on it. And then we're put the text as off, on, off, and on. Did that work, Ming? Okay, great. Now, I believe on this text, instead of just having a, what you want to do here is instead of having a specified text, we're going to point to this dat called color. So let's see, the easiest way to do that is to turn this to viewer. Do I have to do viewer active? No. I can just drag this onto the dat and say I want the dat row to be 0 and the dat column to be 4. No, that didn't work. Because that's a specification dat, darn it. Oh yeah, no, that word does work. I just need to change the row from 0 to 1. There, button off. No, that's not working for me either.
What are you trying to do?
I'm trying to put this column into the actual text.
Can't we copy what they have, some font color, and then just change it?
Yeah, I suppose. Let's see here. Actually, I can do this. No, it didn't work either. I guess it doesn't really matter. For now, let's just whatever. Let's just leave it. Who cares? Actually, let's just delete this button and make a new one because I probably wrecked this button. I'll figure out. I'll remember how I did this in a minute. But for now, let's just let the button be the way it is and put in a button again. And go ahead and send that to a null, right? And then if you click on this, it'll go 0 or 1, right? And we're going to use that to turn on a light. And I think to make this, one thing I do know how to do, go inside the button and down here on this select, which is what's controlling the name of the channel, where it says rename to V1, change that to rename to LED1. This will help us like keep track of what's doing what. So now this says 0 LED1 or 1 LED1. So yeah, you go here on the select inside of the button and down where it says rename to, change that from V1 to LED1. Okay, so that's the first channel that we're going to send, and then but we need to go ahead and make the second channel, and we're going to use an LFO, and set the LFO type from sign to square. So it should go from -1 to +1, but we actually want it to go from 0 to 1. So we're going to actually put a limit chop, and where it says type off, change that to clamp, and set the minimum to 0. And so then it just should go from 0 to 1, 0, 1, 0, 1, 0, 1. And then on this, let's see. Yeah, okay, so then on your LFO, go back and click on the channel tab, and where it says channel name Chan1, change that to LED2. So now we have two channels, one called LED1 and one of them called LED2. We're going to merge these together with a merge chop. And go ahead and plug in the null from your button, and then the limit, and you should have LED1 on the top and LED2 underneath it, and the LED2 is just constantly going from 0 to 1, and the button will change when you click the button. Okay, so now we can do that, and now we can actually send this data to our Arduino. And to do that, to send serial out on your Arduino, on TouchDesigner, it's a little bit more difficult. There's no like specific object for that. You have to do it through Python code. So we're going to use a chop execute, I believe. Hold on. We're going to use a dat execute. So create a dat execute. Dat execute. But in order to have a dat execute, we got to convert this from a chop to a dat. And so we're going to use, coming out of the merge, you right click on that output, click on dat, and you're going to have a chop2 to turn it into a dat. So then you should have it should create a table with a 1 and a 0, 1, 0, 1. Yeah? Okay. Now we actually, because this is a table and we want to actually send a string that starts with that start character and then has the different letters, or the different characters separated by a comma, and then ends with the end of message Terminator character. So, we want to convert this from a chop2 to a text. So use a convert dat. And on there it says how to table. We're starting with a table, so change it to text. And where it says concatenate with /t, change that to comma. So now it's created a text string that says 1, 0 or 1, 1, and it'll go back and forth. Right? Now we need to add that start character, that less than character. So in order to do that, wow, mine keeps changing color. Whatever, it's just noise in the button. We need to use an evaluate dat. So go to dat, evaluate, and we're going to add in the expression for this eval, go ahead and expand the expression and click on the expression flag. And the expression is single quote, less than, single quote. You can start with that for a minute, and you can see then it'll just put that single quote in there. But we need the input value as well. So go back to your expression and say plus me dot input cell, capital C. And so now it should say open bracket 1, 0, like that. Okay? So that has the start character. It doesn't have the end character because we're going to add that when we actually send it out in Python, because there's a function to add a terminator, and we can define that terminator as that greater than character. Okay, so we have our dat execute here. We can now point our dat execute to this eval1. So go ahead and hover over that, or you can drag it over that, and it should create that association. And we're gonna leave it on. Oh no, wait, I forgot a stage. That's okay. You don't have to delete anything. We need to convert it back into a table, because I'm not sure if this is strictly necessary, but I couldn't figure out how to make this dat execute work without it pointing to a particular table index. So just convert it back to put another convert and convert it back into a table. So from to table. And so now it should be a table with a single value with a 0 and 0 index, like that.
Yes.
And now instead, drag that onto the dat execute. So now it's pointing to that instead.
What is the wording? Input dat must be text only.
You drew a line between them, and you shouldn't do that. You should drag it onto it to create the association. You're not going to be dragging a line. Otherwise, if you sent text to it, it would just replace everything, all your code that you put in the dat execute. I did that earlier today and drove me crazy because I had spent 20 minutes coding it, and then I erased it, and there was no way to get it back with undo. So did you delete that line? And then you dragged it onto from the convert. You drag it over to
It has the gray.
yeah, that's what you want. Okay, cool. We're almost there. All right, I'm going to move this back over here to give me some room. All right. So yeah, we're going to have on table change. Let's just go ahead and delete all the other functions that we're not going to use. So we just have the on table change return. And go ahead and add a line in there. And here's where we're going to actually define how to send things out the serial. We need to first point to the serial1 operator. That's this, whoops. That's this guy up here, right? Because this is not only what's receiving the serial, it's also going to be what's sending the serial. So we say op, make sure you tab over, op, open parentheses, single quote, serial1, single quote, close parentheses, dot send. And then we need to have a open parentheses, and then we're going to cast this, the values in the convert 3 as a string. Because remember, our thing parses strings. So str, and then another open parenthesis. And then we point to the op convert 3 op, open parenthesis again, single quote, convert, is it 3 that we did?
The last one?
Yeah, yeah? Okay, convert 3, single quote, close parentheses, and then we point to the index, which is 0, 0, 0, comma, 0, close bracket, close parentheses, comma. So we've pointed to this operator's contents, and we've cast it as a string. And then we put a comma, space, and now here's where we define our terminator. So space terminator. This is a function that's inbuilt into Python. Equals single quote, that greater than symbol, single quote, close parentheses. And your lights should turn on and start blinking once you click out of it and you have it that execute running. Scott's got it. Is yours working?
Something's on.
Is the other one flashing? Is the other one flashing?
No.
All right. Well, the one that's on, click your button and see if it goes off and on.
Okay.
Does it go off and on? No? Well, you either have something wrong in your code or you have something wired incorrectly on your Arduino. Whose is working? Whose isn't working? Okay. Was it not going on before? Okay. Let's see. Do you have any errors? Let me see. Go back. I want to see what your convert 3 looks like. That looks right. And when you click on the button, does that first number turn from a 0 to a 1? No. So something's wrong there. Okay. Oh, it does. Okay. Then there's probably something wrong in your Arduino code. Does that still work? That still works. Okay. Are you guys, Ming? Are you caught up with us and it just doesn't work?
Oh, it's not like very well.
So it still won't work even when you uploaded the thing that I sent you? Error compiling for. Well, you have to go back into this and turn off your serial to be able to send anything to it. So click on serial, turn the active off, and go back into your Arduino and try sending it again. I don't know. It shouldn't matter. Go back into this code. Let's see, what do you got? 9600, go ahead and check your port tools.
So was this working properly before we did all this? Yeah. So
all right. You close your serial port. I want to make sure you're uploading it to the right place.
Let's look at.
Where do you set the port for uploading? I don't know the PC version of this very well.
This is everything we just did.
Go to tools. Port. There we go. Okay, why do you have two different COM4s? That's not right. So save this, close your Arduino out, and reopen it. Okay, comment out all the servo stuff for now. Because you uploaded a version with code we are not using right now, so you got to comment that out. Yeah, instead of deleting it, put a ///. And yeah, and then go down, comment out value 3. Value 3 from PC, comment that out. Go down to the bottom. Where you're parsing, comment out those 2 lines. Okay, upload it again. Upload it.
Yeah.
My servo is not. Comment that out. And there's another thing about my servo. Go up, scroll up to the top. No, I guess that's right. Try uploading it now. Comment that out as well. Try it again. I have no idea what's wrong. That doesn't make sense. Error compiling. It's not telling me. Let me see.
Yes. Is that
expand this.
Yeah.
So I can see what the error messages are. Split data into its parse. Void data. Drop down. Why is it going to this? Is this where you have it saved?
Yeah.
Void parse data split data because it works fine on my computer. Sure. I mean, I doubt that would do anything though. I don't understand this compiling error because it's not telling me that there's anything wrong with the code.
Why didn't we name that LED1 and LED2?
Point to the void parse data. Where's the void parse
No.
data? Void parse data. It says it doesn't like what's after here. Let's do a.
Is it still receiving those? No, it's not.
Oh.
Auto
Hold on.
format.
Can we
Yeah.
turn that
Try it
off?
now. Let's see.
No, go back to Arduino.
No.
Push it to the.
Exit status. Error compiling for board. Maybe there's something wrong with your board.
Jump back into this.
It says error compiling for
Turn that
board.
active on. There we go. That was it. Yeah, yeah. So
So let me see. Hold on.
So what is it?
Arduino thing.
no.
No. Board. Let's see. So get board info. Yeah. Okay. Tools. Still have two COM ports for some reason. I don't know why. Why you shouldn't have two COM ports. All right, hold on. Unplug it. I'm going to program it on my computer and give it back to you. I don't know. You got a Windows problem, I think. Either that or there's something happened to your Arduino. Is yours not work, Shay?
No, that's fine.
Mine said it was using too much power and now nothing.
That's, you have a short. So figure out what shorted. You might have bent your light sensor onto something. All right. So hold on, let me turn my serial off. Go into my Arduino. And I'm going to check tools, port 1421, upload. Does not exist, or serial port does not exist, or your board is not connected. Yeah, you might have somehow broken your Arduino, because I can't get it to work on mine either. Programmer. It says it's done, but it says an error occurred. Protocol error. Programmer is out of sync. Read operation not supported for memory flash. Failed to read all memory flash. Protocol error.
Or here. Yes, that. If you're somehow setting outside.
Let's try to burn a bootloader to this. Is yours working? Oh, okay. Let's see that. Hold on. Where are you? Okay, where do you think you got behind? Starting markers. Yeah. Yeah, well, you don't have anything attached to it now. I unplugged your Arduino.
I've seen crazy things happen.
Well, we're almost out of time. I wanted to get to a thing where we're going to make servos. We're going to make this ball move back and forward on the screen, and the servo actually would follow it. We can still do that next week. That will only take a couple minutes because we got everything we need. Just a few. For those of you whose Arduinos aren't working, I don't know what to tell you other than you might need another Arduino. Because I can't get yours to communicate. So something happened with yours. How have you been storing this? Have you just been putting it in your backpack or something, or? It's possible that it had a static electrical discharge while it was in your backpack or something, or it got smashed or something like that. I wonder. I can't get it to upload anything to yours. Mine works fine, but when I try to program, so like I was worried that there was something wrong with your code or there's something wrong with your settings, so I tried to burn the code from my computer onto your board because my code works. But when I try to burn it onto your board, it doesn't work. So there's something wrong. I mean, I guess it's possible there could be something wrong with your wiring. There could be a short. Let me see here. This little thing here looks like it might be up against that. Let me try moving that. I can't get it to connect to your... Yeah, perhaps, but we're having problems with your board. I can't get your board to do anything. Let me see if I can just do... I can't get it to upload to your board. Tools, port, Arduino Uno, yeah, and I'm trying to upload this, and it says... Oh, there, it worked. This time it worked. I hit the reset button on it. Maybe that did it. All right, so this should be... Now, if I go into mine and I turn my serial back on with your board... No. Oh, wait, but mine might have the wrong port. Hold on.
Should I copy it or not?
There we go. Okay. Okay. It's working. Okay, great. So you have the right code now. I gave you my code, and it's working. So that your board isn't broken. So it should work on your TouchDesigner patch. Okay, so try it now. When you plug that in, you'll need to go into your input. And now mine stopped working. Stop. No, you don't need to upload any code. The code is on there. Just go into your serial and turn it on. Or make sure you have the right port that points to the board, and then turn it on. Why did mine stop? Mine stopped moving. Oh, maybe because it's not getting any. Now you broke my, you broke mine now.
I'm so sorry.
No, mine doesn't work anymore. All right. Yeah. So next week we'll do really quick. We'll look at how we can add a servo motor to this and make it send a third channel of data that make this sphere move back and forth across the screen, and have a servo kind of like follow it with like a little pointer. But let's talk about your homework really quick. All right, everybody. All right, your homework for next week is to start something on your final project. So we'll use part of the class next week to just look at the servo motor really quick. That'll probably take 20 minutes, maybe 40 minutes. And then the second half of class will be a lab time for, whoops, that's not right. This must be not updated. Hold on. There we go. That looks more like it. So your assignment due next week is to have something started on your final so that you can work on it in class next week. And I also want you to document what you have before class on your blogs. So you should have enough of your, you don't have to have your project done, just something, enough of something that you can make a meaningful blog entry about your progress. I've started the graphics on it. I got the communication working between this and that. Something like that. Okay? And then have something to actually work on in class. You should not be starting from scratch next class. You should have something that you do between now and next week that we can then continue working on in lab time during class. And I'll be here to help you advance and answer any questions that may have come up when you did your first part. Does that make sense? Yeah? Okay, great. That's your homework for next class. So the next class is the last official class that we have, May 1st. And then we're going to meet on May 8th, the day before Expo. Yeah. To give your final presentation of your project. And again, your final presentation of your project is you have to give a 5-minute overview of what your project done. It can be there's not that many people in the class at this point through attrition. So we have plenty of time if you want to go more than 5 minutes talking about your project, but do at least 5 minutes. And you need to tell a quick overview about what your project does and how it works. And especially if you're using code from the internet, you better know how it works to the point that I'm going to quiz you and ask you how it works. And if you don't know how a section works, that's not good for you. Because then I'll know you just grabbed code from the internet and you don't even know how it works, right? So that's the most important point. You have to know how your code works and be able to explain that, okay? All right, and then this doesn't make sense. You don't have to document. Well, you do want to document it with video for your blog, but you're going to present it to all of us here in the room on the 8th. But for next week, your homework is to have something started on your project, make a blog entry about your progress, the problems you had, or the successes that you had, and have something for us to work on next week. Okay? Cool. And then we'll do a really quick thing with servo motors next week, so you can see how you can control a servo motor and make it move around to follow your blob as your blob goes back and forth. All right, cool. Thank you, guys.